As we continue chapter 16, let's look at binomial models. What is a binomial model? An appropriate for a random variable that counts the number of successes and a fixed number of Bernoulli trials. So where geometric, I want to count until I have my first success. Binomial, I have a fixed number of trials and I'm going to count how many times I succeeded in each of these trials. That makes sense? So like, maybe I can show you visually. Geometric, I had a no, 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 yes. Oh, took me to the fourth trial to find my yes. With a binomial, I have, let's say, 5 trials, and I'm counting how many successes I had in those 5 trials. I had 2 yeses and 5. So here's our equation where n is going to be the number of trials, p is a probability of success, and q is 1 minus the probability of success. So it's the same thing as geometric. And capital X is the number of successes and n trials. To find our mean, it's a little bit different. We're going to multiply n times p. So the number of trials times the probability of success. That's going to give you your mean. Standard deviation, however, is the square root of n times p times q. So that's how you have to find the standard deviation. And then here's how you find your probability. The factorial of n over the factorial of your x, the number of successes, times n minus x factorial times p to the x power times 1 minus p to the n minus x power, if you were to do this by hand. Luckily, there is a calculator. So we'll see that instead of do this by hand. So binomial as well as geometric, binomial is also within the calculator. Let's look at some examples. The communications monitoring company, Postini, was reported that 91% of emails are spam. So the same example as yesterday. Suppose your inbox contained 25 messages. So now instead of where yesterday are geometric, we want to figure out how many times do I have, how many emails come in until my first real email. Now I have 25 emails and I'm seeing which one of those are actually real and not spam. So my n value is going to be what? How many trials? 25. My P, my probability to get a good email is what? 0.09. And Q, my failure, my probability of getting spam is 0.91. So what is the mean? Well, the mean is going to be n, so 25, times P, 0.09. So somebody real quick in a calculator, 25 times 0.09. What is our mean here? About how many emails can we expect in our 25 messages? 2.25. Realistically, about 2, right? Don't know how you get 0.25 emails. What is the standard deviation? So we're going to take the square roots of our n, so 25, times p, which is 0.09, and times q, our probability of failure. Multiply those 3 together, take the square roots, and what did y'all get? 1.43? Yep. Okay. So what does this tell me? I have an inbox of 25 messages. About 2 of those are going to be real messages, give or take 1 or 2. Right? All right. Next, what is the probability that you'll find only 1 or 2 real messages? First, let's look at OR. Can you remember OR? Do I multiply or add? Add. Very good. So OR is an add. So first I need to find out my 1. Then I'm going to add that to my 2. So here's our calculator. We're once again going to go to second vars, so distribution, but instead of going to geometric, look, we have binomial. And I'm going to go to binomial PDF. So let me bring my calculator up. Second vars, so in distribution, go all the way down to binomial PDF, hit enter. Trials, how many number of trials do I have? 25. P, what is my probability for success? 0.09. And what would you put for your X value? 1. I'm going to put 1 for now. And paste. And enter. That is my probability of all my 25 messages. I get 1. Now, second entry, so I'm going to redo this. And what should I put instead of 1 here? Because I also want to find 1 or 2. So I'm going to put a 2. So I get probability of having 1 message is 0.23. Probability of giving 2 messages is 0.77. And Godfrey told me to add, so 0.23397849 plus 0.2. And my probability is what? About 51% chance I'll get either 1 or 2 emails out of that 25 message inbox. Y'all follow me so far? So we're going to use binomial PDF when we're trying to find the exact number. And I do believe I explained that in the upcoming slide. So here we go. Let's check our work. Very nice. Again, I upload these slides so you can reference them later. All right. Suppose 20 donors come to a blood drive. Recall that 60% of people are universal donors. What is the mean and the standard deviation? And what is the probability that there are 2 or 3 universal donors? So I'm going to have you give this a try. Okay. Let's check our work. I need to find my N, which is 20. My probability of success is what? 0.06. My probability of failure is what? Very good. 0.94. That's going to help me with my mean and standard deviation. So mean equals N times P, which is 20 times 0.06, which equals what? 1.2? All right. So I can expect about 1 of my 20 donors being universal donors with a give or take of, so standard deviation equals the square root of N, so 20, times P, 0.06, times Q, 0.94. And what you get for the standard deviation? 1.06. Thank you. So give or take 1 or 2 people, or 1 person. Could have nobody, or could have 2. But on average, I expect 1. And then, what is the probability that there are 2 or 3 universal donors? So let's look on a calculator. So second vars, binomial PDF, that's going to find my exact value. My N is 20. My P is 0.06. And my value is what? Well, first one is 2. Or 3. And I want to add these together. Did you get roughly 31%? All right. So here we go. Check your work. Looks like we got those answers. Now, you may have noticed PCF. Both of these are very important. So the D in this one stands for density, and the C stands for cumulative. Notice this is where I'm getting this information from if you want to check it out. So here's our problem. A fair coin is tossed 100 times. What is the probability that Heads will appear exactly 52 times. B, there will be at most 52 heads. And C, there will be at least 42 heads. So how would you solve these types of problems using binomial? Well, when you're dealing with exactly, that's when we're going to use the PDF like we have been using, right? I want to find exactly 52 times. So my number of trials is 100. My probability is 0.5 because we're flipping a coin, heads or tails. And I want to find exactly 52. And it gives me about 7.4% chance. So exactly, you're going to use a PDF. Now when you're kind of given a range like at most or at least, that's when you're going to use the CDF, the cumulative. So when you see at most, you're going to use the CDF, same thing with the N and the percentage, and then you're going to put 52. So at most, I'm going to do the exact same thing as exactly, but instead of PDF, I'm going to use CDF. And it's at most 69% chance. I'm going to get 52 heads. So see the difference here. If you see exactly, PDF. If you see at most, CDF. Now when you see at least, what you're going to do is find the at most and subtract it from 1. But notice with the at most, you're going to subtract 1 of the x. So it's going to be 1 minus the CDF, where I keep everything the same, but I'm going to subtract 1 from the at least. So I'm going to find 1 less than that, find that value, but then take the other half of it. Assume 11% of people are left-handed. If 6 people are selected at random, find the probability of each outcome described below. At least 1 lefty is among the 6. So at least. So I'm looking down here, right? I know with at least, I'm going to do a 1 minus. 1 minus. At least is the CDF. So second vars. Go down to the binomial CDF, the cumulative. How many number of trials? Oops. Well, I have 6 people, right? So my number of trials is 6. What is my p-value? What? Sure. What is my p-value? My probability of success. I'm looking for who? Lefties, right? And lefties is 11%. So 0.11. And now for the x value. It says at least. So what would you put as the x value? At least 1. 0, right? So 1 minus 1, I'm going to put 0. So this is telling me at least 1 left-handed people out of 6. And I get a 50.3% chance that at least one of those is going to be left-handed. So it looks like number 3 is about the same. So solve number 3, at least 4 lefties are in the group. Find the probability. At least 4. What's the probability that at least 4 are going to be left-handed out of that 6? So instead of 0, what am I changing this number to? 3. Very good. Did you get roughly 1.8% chance? Yes. 1.8% chance. Number 2, there are exactly 3 lefties in the group. See if you can solve this. There are exactly 3 lefties in the group. Remember what you use for exactly.
For how many? 3?
3. So with exactly that PDF, 6 people, 11% chance of them being lefty. My value is, I'm looking for exactly 3. And did you get about, again, 1.8% chance? Yep, just a little bit more likely. 1.9, I guess you could say, actually. And then finally, no more than 2 lefties in the group. No more than 2. Another way of saying no more than is at most 2. So no more than 2. So with no more, second bars, I'm going to use that CDF. Trials is 6. Probabilities of 0.11. And at most 2. I want to put 2. Did you get 97.9% chance? At most 2?